Good afternoon, everybody. Nice that you are joining us on this webinar on the Aquality app. Today we are going to tell you a bit about this app and how you can use it to collect your own water quality data. I would like to show you a bit about the agenda of today. We are going to first give a short introduction. Then we will talk a bit about the main features of the app and give a live demonstration on how to use this. And then we tell you a bit of some of the previous experiences that we had in our adventures in using the app in the field together with stakeholders in various projects. But first, let us introduce ourselves. And before we do that, you see that you're all muted. And we will want to ask you to ask your questions in the questions part of the viewer that you are using, so that we can then read these questions and we will use that in our way of answering them. And sometimes if there's too many questions, we will also be able to answer them to you by email later on. So first, let me introduce you both to myself. My name is Alice Penning. I am an ecologist at Deltares, and I'm leading the work related to nature-based solutions, especially in the freshwater domain. But with me is also Dr. Joachim Rosemeyer, and Joachim is the main developer of the Aquality app and the core principal investigator for it. But the Aquality team that is managing the app consists of more people. So there is Kim Gommans and Rudy Eckelkamp is of Vivermote. And the app was developed together with the IBM, who has been really helpful in making the whole interface that you are using when you're using the app. So just to tell you a little bit about the app in more general things, it is really meant to measure together. And as you can see, this is not necessarily limited to what happens in the Netherlands, but we welcome participants from all over the world, both in Europe and also globally. You see, even all the way to the other end of the world in New Zealand, measurements are being done. At the moment, there is some 50,000 data points that have been measured with the app. And the app is also available in 6 different languages, and this depends on the setting in your mobile phone, which language it will select for you. So for example, since fairly recently, also a Greek version is available. The app has been around since 2016 and was awarded in the Water Europe contest for technology and innovation with a Digital Water Award winner. Now, just to give you a bit more on why it is so important that we want to give this webinar to you is because especially within the European Union, the EU missions are all asking for solutions to make our landscapes more resilient, both to climate change, but also to restore our oceans and waters to adapt to climate change and to also improve our soil conditions. And water quality is often mentioned as an important topic that is related to these missions. So what we see is, for example, there's a lot of research currently being done to better understand, for example, the role of nature-based solutions and their direct benefits, but also the co-benefits. So it might also be that water quality is specifically a co-benefit of some of these measures. When we are using the Aquality app, it helps to bring both direct scientific inputs, but also it helps to engage with stakeholders. And we're doing this in the various EU projects that both Joachim and I are related to. I am related to the Sponge Works project and Joachim to the Green Hood. And in both of these projects, we are going to use this app to engage with stakeholders related to the project. So this webinar is also there specifically for these projects to also instruct the people that are joining these projects on how to use the app. So welcome to you all. And I would now like to ask Joachim to give some explanations about the main features of the app.
Okay, thanks a lot, Alice. And thank you all for joining this webinar. Yeah, Alice already showed you some background about how you made the app and the use of it elsewhere. I'll just quickly show you the possibilities with the app. This in one overview. So we can, through the app, use your camera to capture nitrate test strip results. We also implemented measuring salinity with the Aquality app. And then on the right of that, you see a measurement list. So you build up your own list of measurements within your smartphone. You can tap on those measurements and look where they are. There's also an option if you have some problems with your camera or with the scanning to also manually put the numbers within the app. And then there's this map functionality, so you can walk around your area and create your own salinity or nutrient concentration map. And then at the far right, there's also within the setting menu, you can look where to get your stuff to be able to measure. So the test strips or the connectivity sensor device. I'll go through these options a little bit more in detail in the next slides. So here is where it all started with, measuring nitrate. Yeah, from the home screen, you can press on the plus button, and that brings you to the camera. This camera is looking all the time for these reference cars that you see in the middle. So it's recognized by the corners, the sort of small QR codes. And then you can put your test strips there, and then the reading of the strip is automized. So the app scans the card, reads the legend, reads the color patch, the upper color patch of the test strip, and then compares the hue and saturation values of the colors. So that makes the reading a bit more independent on the one who is measuring. After that, you will get instantly the results of your measurements. So you see on the right the screen in the blue part, there's the nitrate concentration in 2 units. It's given as nitrate N, but also as nitrate, the lower small number here. And you can add some other information to your measurement. So the location is automatically captured, like the GPS coordinates. The timestamp is also automatically done, but you can also specify your sample type. So whether you sampled, in this case, a drain tube or groundwater or surface water. You can also specify the soil type that you've been measuring. You can. There's something about how private or public you want to have your measurement. I will show that later, how that works. And then you can add a comment or a description to your measurements, like a measurement location, or I was in this pond or at that river. And then you can submit, and then you share your data with the general public or with the monitoring group that you're part of. Upon request by many farmers, actually, who wanted to measure nitrate, they also liked a lot the opportunity to measure nitrate in the soil, because the upper soil, that's most crucial for them to grow crops. So if you can measure the nitrogen or nitrate content in the soil, that can be interesting for farmers. They can have a look if it's needed to apply more manure or fertilizer, and also at the end of the season they can see, okay, is there still some left, or did I tune it very well, and is everything used by the crops? So we made a sort of simple protocol of an analysis that is normally done in the laboratory. You need for this, of course, the test strips also, and the reference cards. And for the rest, some water and not containing nitrate. You need a kitchen scale and some toilet paper and a bottle. So what you do is you bring some water in this Doppler bottle until the first stripe, and then you fill it with your soil sample until the next one. You weigh the amount of the soil sample, so that's why the kitchen scale is there. And then the magic toilet paper trick comes in. So normally in the laboratory we would filter the sample to get a non-turbid clear water sample, because of course when you shake with soil you get very dirty turbid water. But we found out that putting in a piece of toilet paper is a way to extract some clear water. So the water will suck into the toilet paper and will become clear in the upper part. And you can use that top water to squeeze out the drip on the test strip. And for the rest, the measurement is similar as the one shown previously for the normal nitrate measurements. And a recalculation back to the amount of nitrate in the soil solution and in the soil itself is done by the app itself. Okay, the next option is to measure salinity. This is especially interesting for farmers that are farming in coastal areas. Sometimes they have to deal with intrusion of saline water via the surface water system, but also maybe via the groundwater system. For this, we are using HANA DIS4 connectivity meters, and actually the app can just read the numbers from the screen. So it's just an easy way to very quickly read this device and share this data, store the data within the app. You can use the same menu to add information about your measurements or to add the comments. And this was actually done, commissioned by a province in the southeast of the Netherlands who wanted to work with farmers and students to collect salinity data in the area. And then, again, upon a lot of requests from farmer groups using the app, we also implemented the option to store phosphate and ammonium data within the app. We didn't make a scanning connection like we did for connectivity. You just use your field device to measure ammonium or phosphate, and you can use a manual input to give in the measured value, and then you come again into the menu to add the other information to your measurement. We've been using for this these checker pocket photometers that you see on the right. So the upper one is for ammonium, the lower one is for phosphate. And these checkers go for around $95, and you need some reagents, so you also have a little bit of cost for each measurement. Okay, and then I wanted to share with you some information about how accurate the measurements are, especially for nitrate. We use the test strips, and those are not officially certified lab measurements. So the precision is not as good as the measurements in the laboratory would be. But when you're a bit experienced, you can really get it within like 10-20% inaccuracy, so 80 to 90% accuracy. And these are actually some testing results done on the left side by the Water Board Limburg. So they took samples in the field for analysis in the laboratory, but they also in the field did Aquality App measurements. And they found a good agreement between the two. And the right one are laboratory tests by SEGAS, that's the agricultural corporation in Denmark. And they've also been testing at different temperature levels. So it's often cold in Denmark as well, so also at 2 degrees Celsius, but also at more lab temperature or summer temperature 20. And they tested that with reading the strips after 30 seconds and after 60 seconds. And this also shows you why we recommend to read the strips after 60 seconds, because there's a lower temperature effect. So also at low temperatures, you get a good reading for nitrate, as you see in the right graph. So those were some insights in how the app works. And if you want to ask us questions, feel free to type them in the place in GoToWebinar for your questions. I haven't seen any questions appearing just yet. Did you have questions,
No,
Alice?
I think it's very clear. And what we're now going into is also to show you in practice how it works. So perhaps while we'll do that, you can use the chat if there's any specific questions, and we will discuss the questions after that. So I would just say, otherwise, let's just continue with the third part of the webinar, where you're going to give a little live demonstration.
Yeah, okay. There we go. And this is, of course, always super risky to give live demos. But I can share the screen of my phone. You can see it now. So this is the start screen that you will see after accepting some things like access to the camera. So this is just a list of the measurements that you have been doing within the app. It's now on nitrate, but you can also go to the list of salinity measurement and phosphate. So I'm just swiping to the right and back. Yeah, first of all, I will just show you how a measurement of nitrate goes. So you can press on the plus button, and then the app is using the camera. I have the test strips that we use here. I forgot to say, but these go for about $25. These bottles, and they contain 25 strips. I need 3 hands to do this. So, and I prepared some water, and I'm already I added a little bit of plant fertilizer to it. So normally you would just dip in the strip for 1 second, and after 60 seconds read it and compare it to the legend on the bottle. And now I'll just put it on the reference card. You can already see what the reference card is doing. If it sees 2 of these corners, then you see a blue cross appearing, and when it has all 4, then it gets a green rectangle, and that's when you can scan the card. Okay, there we go. So the test strip, just for 1 second in the water, and we tap it off just to get rid of the excess water. And then you can use the timer to keep track of the 1 minute. So you have plenty of time to put the strip on the reference card. We advise to already look a little bit. Okay, where do I expect the measurement value to be? It doesn't really matter where exactly the test strip is, as long as it's on the black part of the reference card. And maybe good to say that while we are waiting for the counter, especially indoors, you can make shadows with your phone, but you can also in direct sunlight, you can also have problems with shadow transitions on the cards, and of course those have impact on your measurement. So you can block the sun with your body, for example, or go to. Okay, now the 60 seconds are over, and I can tap the button to get the measurement value. It's always good to check if it corresponds with what you think based on your visual reading of it. Okay, you see the results again in 2 units. So the upper one, 25, is nitrate N, and the lower one, 110, is as nitrate. The time is fixed. I will set the measurement type to other, and then the soil type here in the peat, but I'll put other at that, and then a description. I'll just say test. Test. Okay, and then there's a submit button. If I press that, then the measurement is submitted, and it appears in the list. I can also tap that, and then there's also the option to after submitting to still edit the measurement. So for example, I still want to change this, for example, to groundwater, and save it, and then it's stored as a groundwater sample. And it's also possible to change the location where you took it. So you can also say, okay, well, this is where we are now, but actually, I took the water here from our tetra pond, as we call it. Set the location, save, and then this measurement is stored there. That is also something that we implemented together with IBM, by the way, because farmers told us that they often took some sample back home and measured there. So now they can put the measurement at where they took them. Okay, yeah, via one of the lower buttons, you can access the map functionality. So this is the measurement that we just did. So you can see that measurement, but you can also see what others have measured, and that's for all the measurements that have been shared publicly. I can go zoom out a little bit further, and you can see there's also some people in Poland, Denmark, France who have been measuring. I also saw, so this is just for April, some measurement in the US, in Mozambique, and in New Zealand. And you can go back to your own location. If you don't see the measurements that you are expecting, there's a filter button on the lower right. And here you can switch between, for example, the parameters. You can go to salinity. And you can also look at your own measurements. And you can use another type of map. So if you prefer the more the topographical map, then you can also show that. These are the salinity measurements, especially in the southeast of the Netherlands. They're done a lot. And you can go back in time to look at other periods. Okay. I also want to show you can go to the plus for new measurements. I wanted to show you how a salinity measurement is done. This is the HANA Disphere salinity meter that we use. They also come in blue, but I have a white one. Turn it on and put it in the sample, and then the app, because of the little sticker on top of it, it recognizes the screen, and you can tap, and then the measurement value is taken from the screen. And again, you can say the water type, the soil type, and a remark. So that's how you measure salinity. I wanted to show you some other feature, because sometimes farmers especially, they don't want the measurement all in the open. So we also implemented the possibility to not share your data, but to keep it for yourself, or to share your data just within a group. So if you go here to the right, there's this icon for the login. I'm now not logged in, so then you see this. If I click on login, then you can, for example, use your Google account to log in. So this is what it looks like once logged in. And you can see that there's a button with groups, and I can show you how easy it is to create your own group and start measuring. So it's just a new group name, webinar, and description, Alice, and Joachim, done. And then you can add others to your group by the Aquality ID. So that's the number that you saw on the previous screen. I'm already there, but I can add Alice. I just learned that her ID is 143209. So there she is. So now I'm in a group with Alice. I'm done. And now when I do a new measurement, I will enter it manually for now. Like, let's say we're doing a phosphate measurement. Value is 2. I'm done. And then here in the menu, you have an extra option, the privacy and sharing option. It's now put on private. So that's the default after logging in. But you can also say, okay, I want to share it in the group. For example, the group with Alice that I just made.
Webinar.
The webinar. Thank you. So. And then, yeah, the measurement is just visible for me and Alice. If I go, yeah, there's also this this filter in the list of measurements. So if I say, okay, I want to show only the measurements for this group, yeah, then it only shows this this measurement of 2 that I just did. But yeah, others won't see this one. Okay, and oh, that's also for the map. You can just show your private measurements, but it's also possible to see the measurements of a specific group. And then I have to go to here to phosphate because we just did a phosphate measurement. And there it is. Okay. Yeah, maybe one thing to show you is also the setting menu. So here you can set all your default parameters, like if you're always measuring in cents, like I usually do, you can put your default soil type on cents. You can have a default surface water type. You can change the nitrate unit that you prefer. Some people like nitrate N, but others nitrate. Same for phosphorus. And you can also set your sharing yeah, on the default. So you can also, okay, most measurement I want to share publicly. So you put it on public. So for each measurement, you can still change that, but you can also put it in the settings so that you don't have to change it every time. And yeah, here you can also ask questions to our email address, and the lower one is what I already mentioned. So you can have a look where you can order the test strips, or where you can get the reference card, or the salinity meter, or the sticker that you need on the meter. So that was a very quick tour of the app and its functionalities. I think we can now go back to the PowerPoint, and I think that yeah. You can still keep going on asking and typing your questions, but we can also have a look what's already there.
Yeah, there is a question here that is the quality of the camera of influence on the result?
Yes, a little bit. We sometimes see small differences between cameras. And that's also depending on the quality of the camera, of course, the light conditions. So that's why I just gave the advice, try to measure in the shadow, because some cameras are not so good at when there's both very, very light in your image and very dark, then it's starting to stretch the colors a lot. And the cause of that will be that your legend scale, the colors, they look more similar. So if you can block the sunlight, then you have less problems with the big difference between light and dark. Yeah, so the short answer is yes, we see some slight differences between phone types, especially, of course, for all the different types of Android phones.
Hey, and there's a few questions that are a bit related to how the data is stored, and if it is possible to extract the data from the phone to do further analysis on it, for example, on your computer.
Yeah, that cannot be done directly from the smartphone, but we have a web platform for that. So if you go to our website, we have been giving a QR code, but you can also Google Deltares Aquality. There's also a link to a web platform, and there you can download a CSV file for all public measurements. But if you use the group functionality, or you have stored measurements as private, you can get separate CSV files and download that for your own group, and then you can work in it within Excel or within GIS, or You can even, there are some organizations who have a sort of live link via an API to take over the measurements instantly on their platform.
Yeah, very interesting. And you showed some of the comparison with the lab for the nitrate, but did you also do that for the other parameters in the app already?
Well, the salinity measurements are really accurate with this device. So that's really between 1% and 2% maybe in accuracy. We also tested these HANA checkers for phosphorus. They are not as precise again as lab measurements, but they're close to that. So also if you have your own salinity measurement device or your own phosphorus ammonium device, you can also use that and use the manual input to store those data. But be aware that you use the correct units. Especially salinity can go in different units like milli or microsiemens per meter or centimeter. But also for phosphorus and ammonium, you have to check that. And be aware also that phosphorus, it's with this device you only measure dissolved phosphorus, so it's not all the phosphorus that is particulate, so that's attached to particles in the water.
Yeah, that's good to remember indeed, right? And there's another question also related to what are the parameters that you can sample, like for example, are other parameters also considered, such as pH?
Yeah, we have been considering pH and also some others. For now, we have these four, so nitrate, EC, phosphate, and ammonium. And that's actually our main target group. So the farmers and the farmer advisors, we listen to them mostly. What do they want? What parameters are they interested in? So for now, like if you want to add pH values to the app, it's the only option is to put it in the comments. If you have a location where you also measured some other, you could also, for example, if you have a tube drain, you can measure the discharge of it. You can put it in the comments, but we don't have a separate parameter field for that.
Yeah. And then there's another question that says, like, I've tried the nitrates once and it was really helpful for screening tests. I don't remember if there's a detection limit, high or low, for all of the parameters. Is there a certain range within it for operating it?
Yeah, for nitrate, everything below 1 milligram per liter, you don't really see much color change on the test strips. So it's good to check, of course, before you implement it somewhere, that you have concentration values above that, because otherwise your stakeholders or participants are always getting zeros, and that's of course not so interesting. The salinity.
What a good result if it is what they're after, right?
Oh well, zero is always nice, and well, not always for the farmer, by the way.
Yeah.
The salinity measures, they go very low. So also in rainwater, there's already enough salinity to measure with this device. The HANA checkers for ammonium and phosphate, they go in different ranges. So you can check their availability. They have a very low range, but also a somewhat higher range. So you can also check there, okay, what range of values do I expect in my area, and what device matches best with that range.
Yeah. Hey, and there's also a question to see that, can the app create graphs or report by itself?
No, that is on our wish list, by the way. To be able to make a graph of your multiple measurements at one location, you also have to connect each measurement to a location. We have done something like that based on the coordinates, but sometimes we have different samples very close to each other. If you're within 5 meters, the GPS doesn't really see that you're sampling different water. When you're at a splitting waterway or something. So then you go wrong with just showing time series based on the GPS locations. So for that, we would like to connect the measurements to locations, but we haven't done that yet.
Yeah, I can imagine that is another bit of, you see that this app has been evolving over time as well. At first it was called the nitrate app, and now we're already having more parameters in it. So yeah, that depends also on what's the demands from the users as well, and what can be done. There's another question here is on how we can buy the tools before using the app. So I think this is related to the little measurement devices and also the salinity app and the little strips. Can you explain it a bit more?
Yeah, you can, well, within the app, as I just showed, there's within the settings, you can go at the lower end of the settings, there's a sort of in-app web shop. So there's information where you can order the test strips, where you can order the reference cards, where you can order the stickers for the EC meters, and also the EC meter itself. Yeah, and otherwise go to our website. There's also an instructions document, user instructions.
And then is there any advice for how users can do dilutions when measured concentrations are above the instrument threshold?
That's a very good one. No, actually, we haven't really have specific instructions for that. Of course, it depends on yeah, how high it is. So if you can just mix it 1-to-1 with nitrate-free water, for example, you would have to do the manual input then, I guess, because the concentration that you get from the app has to be multiplied. So well, yeah, so there's no real option to say within the app, okay, I diluted this sample. So that could be a nice also addition, although the nitrate, it can go up to 50 nitrate N. So if you're above that, then I think there's a problem anyway,
yeah.
especially when it's drinking water.
Yeah, no, and it's good to know that there's also a manual change that you can do. So if you're trying something and you make your own method, if you keep that method and doing it, yeah, consequently in always the same ways, always having the same method for that, it's up to you to keep a track of that. But it is possible to at least put the number in. I think that is all for the questions right now, but let's otherwise just show a few more examples for you to give you some inspiration of how the app is actually being used in practice in projects around the world, starting with the one for which the webinar together with the next one as well in Greenhood was initiated. In SpongeWorks, we are implementing nature-based solutions for water retention and climate resilience in Europe. So these measures, they are often nature-based solution measures. And what we always say is that with these types of measures, there's a lot of co-benefits that come from them. And some of them are related to water quality. For instance, if you're reconnecting a wetland, can this then also improve the water quality in the area? And in a way, this is also helpful because it can help us engage with stakeholders who are having to implement these types of measures so that they are really involved in getting the measures implemented. And we're doing this in 3 different basins throughout Europe, in Greece and France, and in the Netherlands, Germany, Vechte basin. So this is starting now, and in the coming 4 years, we will keep track of how we can use this app together with all the different stakeholders. These are farmers often and municipalities that are all very interested to learn more about water quality in their own location. Joachim, would you want to tell something about Greenhood as well?
Yeah, more or less similar story for Greenhood. It's a recently initiated EU project working with stakeholders and research groups in Norway, Finland, Spain, and Netherlands and Belgium. It's all about rebalancing the nutrient fluxes, so trying to keep the nutrients as much as possible within catchment areas, reuse nutrients, try nature-based solutions as well to reduce nutrient losses. Well, and we will be using the Aquality App, yeah, like the map shows here, to show within the research catchments, so where exactly are nutrients actually coming from and what route do they take. So this is both measurements from the stream, but also from the little side ditches, and also the tube drains. So you can really allocate some hotspots where you can then see if there's a solution, of course, together with the landowner, with the farmers. And you can, if you have implemented the solution, you can also use the Aquality App to have very instantaneous measure of the effects. You see on the right side an example where we implemented a wood chip bioreactor to purify tube drain water. And you can measure the water that goes in and the water that goes out. And you can do it also with visitors and with the farmer himself. So this is really nice. You don't have to wait for a couple of weeks before the lab results get in. You have an instant idea about the effect in this case. Water with around 7 milligram per liter and energy and went in, and 0 went out of the filter. Yeah, we have some other examples of how it can work. If this also works. Yeah, so mostly in our studies we use the Aquality App to go around in catchment. So we start at the regular monitoring location of a water authority, and we want to look more into the headwater streams and into the really small contributing ditches. So we just walk along the brook. It's always a very nice thing, also even to do in the weekends. And we also measure all the little ditches that contribute discharge to the mainstream. And then sometimes you meet a stream, in this case, where the somewhat larger red dots are placed. In this case, almost all the nitrate came from this one ditch, and it only drained two farms. So as a water manager, you can leave a lot of farmers do their thing, and you can just go to those 2 farmers to further investigate what happens there and what may cause these higher nitrate losses. So it has been used like that by a couple of water boards in the Netherlands. The picture on the right is an example, where they found some high concentrations value, and they started looking. The nice thing is that you get your results instantly, so you can take your decision in the field where to go next and where to find where the source is. And in this case, there was a glass house with a spill that could easily be removed, because he could also drain this water to a sewage system. So this is one of the examples where we actually made some improvement to the water quality in this area. Another example is more focusing on salinity measurements. So this is in the southeast of the Netherlands. We have a province that's surrounded by salt water, both at the sides but also on the bottom from below. So the groundwater is also brackish. And the province, so the provincial government there, they wanted to collect really detailed measurements. So not just their main locations, but also the small ditches and even tube drains, to see, okay, where is exactly is the water still fresh, and where is it too salt? The farmers were very keen on measuring this, because they need some fresh water to for irrigation. It depends a bit on the crop, how much salinity it can have. But for example, there's a lot of fruit made there, like apples and pears. They need irrigation water, but it should not be too salt. It was a big success. Every month our map was full of measurements, and in total they collected about 6,000 measurements. And there were really quite some farmers who were really enthusiastic, and like this feedback that's shown. Some of them really made their weekly round among their fields, and learned a lot about the water system and about their freshwater availability, and also together with their neighbors. So they were keen on continuing these measurements. And by the way, I also have to say that there were also students involved here. So a lot of students also went out and did entire transects through this area. It's also super nice to do it with a very, very young students. So these are 11-year-old kids in my hometown. And we just had 2 hours to do some samples. So what we did is we went to the location where water enters the village. We find a very low nitrate concentration of about 1 milligram per liter. And then we went to the location where the water left the village, and there it was about 3 or 4 milligram per liter. And after that, we started to look, where this nitrate and also some extra salinity, where it came from. And we found that it came from a sewage treatment discharge location. So treated wastewater that was joining this stream. And we even found some ecological effects of that. So we saw water fleas swimming around in the nitrate-free water, but in the nitrate-rich water there were no water fleas. This was super nice to do with this group. Another topic that we have been trying more abroad is to look at how safe the drinking water is. And this example comes from a project in California, in the Central Valley. It is known that many people in the rural areas, they have their own groundwater pumping station, so they pump up their own drinking water. But in general, they know that about 10% of those wells have too high nitrate levels for health. So above the 10 milligram per liter nitrate N or 50 nitrate. But it's 10,000 of those domestic wells. So you cannot send everything, sample everything and send everything to the laboratory. So the Aquality app can be used as a sort of pre-screening to see, okay, if there's high nitrate, you can select the well to sample officially and send a measurement to the laboratory. Also, because nitrate, it's not just about the nitrate, it can also be an indicator that some other anthropogenic contaminant is reaching your drinking water well. Sometimes this pollutants can come from the agriculture in the surroundings, but what also happens sometimes is that people have also their septic tanks and they drain, and sometimes that connects with their domestic water well. So that's of course a health risk also for pathogens that you can drink. To end with, because this is, I think, what I like most, using the Aquality app to raise awareness as a starting point for further discussion about what mitigation options could be appropriate. This is an example on the left about the Netherlands. We have our national monitoring, but farmers are always struggling a bit. What is actually my contribution to the bigger problem? So based on these national monitoring networks, we make new legislation, and that's put upon all the farmers in the Netherlands. And the farmer, they are not knowing, they are obeying the rules, so they assume that they are doing a good job, but actually they don't know because they don't have the information about their own farms. So we are looking towards maybe try to go out measuring together with the farmers, to involve them in monitoring campaigns, so that they can see themselves, okay, I'm doing indeed a good job, or maybe on this and that field there's some more nitrate loss than I had expected. And for a farmer also, nitrate, losing nitrate is actually also losing money, because he applied too much fertilizer, so he can reduce that a bit. But also for the water manager, in this case, the person with the blue clothing, for him this is an interesting way to get into touch with the farmers, not immediately start fighting about what he should or should not do on his farm, but first try to collect information and then select where and what mitigation would be best for this farm. Okay, these were our adventures and our examples. We wanted to say that we are still making some really short instruction videos that will be coming on our website soon. There are some links here and email addresses that you can use. And most important is to get the supplies and try it, and go out. And we want to wish you a lot of pleasure doing that. And maybe good to mention, this webinar is also recorded, so you can look it back on our website. And then, yeah, maybe we can have a look if there are still some more questions that have come in.
At the moment, I don't see any new questions, but let's give people a few minutes to see if they want to type something, if there's anything that they still have. It seems the last part was pretty clear as well, right?
Okay, yeah.
And of course, we are always open for questions via reaching us directly. Indeed, it says it was very clear. Thank you very much. So other than that, I would say we just close the meeting for today. Thank you all for joining. It's been a pleasure, and we're looking forward to continue the work with Aquality App together with you. Have a nice afternoon. Bye-bye.